Today we're going to look at Unit 3, Lesson 1, Perpendicular Bisector of Segments. Here's our vocabulary words for the section, so make sure you have the definition written down for each of these words, or look back at your notes that you did on the vocabulary so you can see what the definition is. So we're going to start off with some theorems. So the first theorem we have is Theorem 1.1, Perpendicular Bisector Theorem, and it says if a point is on the perpendicular bisector of a segment, then it is equal distance from the endpoints of the segments. So CD is our perpendicular bisector right here. As you can see, it makes that little stand, which stands for perpendicular. So if CD is a perpendicular bisector of AB, so we have AB, then AC equals BC. So basically the bottom part down here is cut by CD. So this part right here and this part right here are the same. Theorem 1.2 is the converse of the perpendicular bisector. So it says if a point is equal distance from the endpoints of a segment, then it is on the perpendicular bisector of a segment. So in this triangle above, if AC equals BC, so if these two are equal to each other, then C lies on the perpendicular bisector of AB. And then the circumcenter theorem says that the perpendicular bisector of a triangle intersects at the point called the circumcenter. That is equal distance from the vertices of the triangle. So we'll come to that in a little bit. Let's take a look at our first example. Use the perpendicular bisector theorem. So we want to find EF. So we have EF right here. We want to find that. So we know that FG is the perpendicular bisector of EH because we can see the little right triangle right, or the little right angle sign right here. So we know that EF equals HF because that's what the theorem tells us. So we have that 4A minus 15 equals A plus 12. So I want to solve this equation. So I'm going to start off with getting A on one side. So subtract A from both sides. That gives me 3A minus 15 equals 12. I'm going to add 15 to both sides. That gives me 3A equals 27. Then I'm going to divide by 3. So A equals 9. And it doesn't matter which one we plug it into because as we said, both of them are equal to each other. So I'm going to plug it into the first one. So 4 times 3, or sorry, 4 times 9. 4 times 9 minus 15. So 4 times 9 is 36. So this gives us 36 minus 15. So that's the length of EF is 21. So this is 21. And this is also 21 by the theorem. So now we want to use the converse of the perpendicular bisector theorem. So we want to find the length of xy. So we want to find the length of xy. So that's this part right here. So because wx equals wz, we know that we have this perpendicular right here. So we know that wy is perpendicular to xz. So WY is the perpendicular bisector of XZ by the converse of the perpendicular bisector theorem. So by the definition of the segment, XY equals YZ. So XY equals YZ. Well, X or ZY equals 22.4 or YZ equals 22.4. So XY equals 22.4. Now we're going to use the circumcenter theorem. Find BF if D is the circumcenter of the triangle. So D is the circumcenter of the triangle. So DE, DF, and DG are the perpendicular bisectors of the triangle. Because DE bisects, so DE, let's right here, DE bisects AC, we know that EC is half of AC. So we know that this part right here is going to be half of this whole thing. So EC equals 1/2 of AC. And it gives us what AC is. It says AC is 9. So we know EC is going to be half of 9. So 1/2 of 9, which is 4.5. Now, what we want to do is we want to find DC. So we want to find this part right here. But we know DE. DE equals 1.83. So I have this, I'm missing this. Well, I notice this is opposite, so I'm going to use Pythagorean's theorem to find DC. So A squared plus B squared equals C squared. So plug in what we have. So 4.5 squared plus 1.83 squared equals C squared. We're solving for the hypotenuse in this case. So 4.5 squared is going to give you 20.25, so 20.25 plus 1.83 squared is going to give you about 3.35 equals C squared. Add these two together, so that's going to give you 23.60 equals C squared. Now I'm going to take the square root of both sides. When I take the square root, that undoes the square. So instead of C squared, that's just going to give me C equals. So I'm going to take the square root of 23.6, and that's going to give me 4.86. So we have that this right here is 4.86. So we have DC, and by the theorem, we have dB as well. So DC equals dB. So DC equals dB, which equals 4.86. Because if you look here, that would also be a right angle, so opposite that is going to be there, dB, and we have that's 4.86. So we have dB as 4.86 as we just said. We have dF, it gives us dF. In the beginning it says that's 1.53. So it gave us dF right here, 1.53. So I can find BF right here. How can I find it? Well, I'm going to use Pythagorean's theorem again. So A squared plus B squared equals C squared. So again, I have c squared. I have one on my side, so I'll just say that's a. So I said df is 1.53. That's given to us. We're trying to find bf because that's what our original question asked for. It asked for us to find bf. So that would be plus b squared, which is bf, equals c squared, we said, is 4.86, which we know when we square it out is 23.6. So that's going to be 23.60. So square out 1.53 gives you 2.34 plus b squared equals 23.60. So subtract 2.34 from both sides. Then you're going to take the square root. And once you subtract it and you take the square root, you're going to end up with 4.61. So BF equals 4.61. So I'll put that right here. We'll put it right here. BF is 4.61. And then I'll highlight that up. And then this one is going to be 62.12. All right. And then for number 4, we're going to hold on to number 4 for right now. We're going to come back to this at a later date. All right. So we're going to use these questions to answer the practice problems. So you're going to write a summary down here of the 3 theorems that we learned about today. So what do the theorems mean in your words? What is the perpendicular bisector theorem? What is the converse of the perpendicular bisector theorem? And what is the circumcenter theorem mean to you? And then use this to help you answer the practice questions.